So what is the pH of a 0.100 hypochlorous acid solution here? Okay, so hypochlorous acid is HClO plus, I'm going to add H2O, sorry. It's going to give me ClO minus plus H3O plus. And then my Ka here is 3.5 times something. Let me just Google what the Ka of HClO here. Let's see. 3.5 times 10 to the negative 8. That's our K value. Okay, so it's finding out what the pH is. So simply we have to do is ICL, right? So ICE. Our initial concentration of hypochlorous acid is 0.1. We don't care about the water again. So here is 0 minus x plus x plus x. 0.1 minus x, x, and x here. So what we can do is we can write out our equilibrium equation, right? So we have Ka, which is 3.5 times 10 to the negative 8. It's going to equal the concentration of our products, so ClO minus and H3O plus our reactants, which is HClO. It's going to equal x times x over 0.1 minus x. So it's going to equal x squared over 0.1 minus x. Now, as you can see, I can do the assumption method. I can cross out this x here because this, I'm assuming that this is very, very small. So which means I'm going to get 3.5. If I move 0.1 to the other side, times 10 to the negative 9 equals x squared. I can square root both sides. So x here is going to equal 3.5. 3.5 times 10 to the negative 9. It's going to equal 5.91, or 5.92, sorry, times 10 to the negative 5. And this here is also equal to the concentration of our hydronium ion. And finally, what we can do is we can solve for the pH, right? So pH is simply just negative log of our hydronium ion, which means that we know it's 5.92 times 10 to the 5 molars here. So pH is simply just the negative log of our concentration of our hydronium ion, which is going to equal 4.23. So this solution here is correct because they had 4.23 as the solution. As you can see, 0.000592 is 5.92 times 10 to the negative 5. So this solution is correct. Good analysis.